So in this video, I wanted to show off something that I've been working on for a while now. I've been developing a racing game, and while I was doing that, I realized that I needed a tool that would allow me to make some crazy track shapes. So, I guess this video is for you if you're trying to build 3D racetracks, or maybe you're doing something like a roller coaster game. But I mean, if you've been doing that, likely you've probably run into some issues in terms of trying to do that with splines. And I'll explain a little bit what I'm talking about here. So, normally if you're going to be building a racetrack, you're going to probably start with the spline, kind of like what I've got here. You're going to lay out your spline points where you want them to be. You're going to kind of rotate them into position. And then you'll use that to populate instances of a spline mesh component along it. The problem is let me just enable my visualizers here. So when you have anywhere where your spline runs in the same direction as what's called the spline up vector or the default up vector, you're going to get this ugly twisting at the spline points here. And this happens because of the way Unreal does some of its vector math to figure out the roll, sorry, not the roll along your spline, but the where it thinks that the spline should be facing. And so I've seen lots of posts on the Unreal forums, for a number of years talking about this. And it was only during my research I came across an old post by a guy named Chris Murphy on X, where he had managed to solve this problem, and he had some custom components that he built for that. But when I tried, when I tried that in Unreal 5, it didn't work for me. So, essentially what we're seeing going on, like this point here and this point here, this isn't a bug in Unreal. It's really just a design limitation whenever you're using splines or SplineMeshComponent. And what Unreal normally does, so when it deforms a mesh along a spline, here I'll just show you what that looks like. So if you go to deform a spline or a mesh along the spline using a SplineMeshComponent, you're going to get something like this, and you're going to have all of this ugly twisting. And the reason why that happens is because at every point along your spline, Unreal has to figure out what's called a local coordinate frame. This is essentially an orientation that tells Unreal how it should be stretching and orienting every vertex of your base spline, your base static mesh. And so essentially, I mean, I won't get into this too much, but it happens pretty much at the places where it runs in the same direction as the spline up vector, because it's got to take the cross product of the tangent of your spline. So in my case, as I'm coming around this loop, it's pointed upwards, and then on the way back it's pointed downwards, and it crosses that tangent with the default up vector. And if you're doing your vector math and you do the cross product of two parallel vectors, it's 0. And so because of that, Unreal doesn't know how to produce a vector that is the correct right angle or the correct perpendicular to your tangent. And so it kind of just comes up with something and something crazy, and so you end up getting this twisting. So the simple fix that you see talked about a lot is, well, just change the default up vector to another direction that you don't use. Problem with doing that is that if you're working on a 3D racetrack like this, like you might solve your problem for a flat track, but for something like this, you're actually occupying every direction in 3D space. So if I go to change this to let's say any other vector, you can see that the problem just goes to another place. I can't actually get rid of it. Doesn't matter what vector I choose. You're going to have the same problem. So to fix this, we need a different way of calculating those local orientation frames, one that doesn't rely on any fixed direction in space. And so what we can do for that is we can use an approach called parallel transport. And what parallel transport does is it starts with your beginning of your spline. It builds a frame for that. So in this case, my frame is up, right, and forward. And then it propagates that up direction along my spline, kind of using the control points as guides for how that should be changing. And so, so here where my control point is pointing upwards and forwards here, it's propagating that change. It's keeping it consistent with this. When I get to this point here, it realizes that it needs to rotate the up vector from here to this way, and so it does that kind of stepwise, and it sort of propagates that change all the way around until it gets to the beginning. And so, what that looks like, I'll just turn on my parallel transport here, and boom, problem solved. Look, no more twisting. If I go in and I show you what the positions look like. So, we're starting over here. This is our first spline point, and you can see that it's maintaining that direction. So the greens are the binormals, the blues are the normals. And even when I come up to this spot here where everything's all twisted around normally, it's relying on the frame here, which is relying on the frame here, which is relying on the frame here to keep that right vector going in the direction that I want. And so, once I have that, then that's the information that I use to build all of my mesh deformation. And so, it wasn't exactly the solution was a bit non-trivial to put in place, because normally when you're working with spline mesh components, Unreal doesn't make a new mesh for you. It's a bit of a visual trickery where it takes the spline information, it passes that to the shader, and then the shader figures out from the spline, it does all of the math to figure out where the vertices need to move. And so, when you're doing something like this, because the whole system is connected along the whole spline, any single vertex can't just look up and figure out, well, what was the position of the frame before me? So I had to figure out a way to sort of build all of that information on the parallel transport frames, send that over to the shader, in addition to all of the spline information that Unreal normally does. So, it was a bit of a challenge to do, but the result, I think, speaks for itself. Looks great. It's let me make some pretty crazy looking tracks, and so if you're interested in learning more, leave me a comment, and yeah. All right, thanks for watching.